Before we delve into the statement, it's important to first understand what molecular fuel petals actually are. A 17-mile superconducting magnet ring makes up CERN's Large Hadron Collider, or LHC. The pinnacle of human achievement, it stands as the world's largest and most remarkable atom smasher. In fact, it is so powerful that it can recreate the exact conditions of the universe's first moments. But is it possible that the machine designed to solve the universe's mysteries holds the key to something truly unique? Founded in 1954, CERN is one of the most renowned research institutions worldwide, with 23 member countries and numerous scientists. It serves as a meeting place for creativity and teamwork. Although the Large Hadron Collider, LHC, is CERN's primary project, it is only one component of a vast network of experimental studies and fuel petals. This infrastructure is designed not for motors or humans, but for subatomic particles in a test of endurance and the very fabric of space itself. The LHC accelerates protons close to the speed of light, steering them into a collision course that mirrors the energy released during the Big Bang. These collisions generate temperatures far hotter than the sun's core. A vast array of magnets directs the protons on their path, while sophisticated cooling systems maintain the magnets at temperatures lower than outer space. The beams in the LHC are made to collide at 4 distinct locations across the accelerator ring, interacting with 4 specific particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a distinct purpose in the study of various aspects of particle physics. Together, they act as enormous cameras, capturing images of these collisions. Scientists then analyze the resulting particles, searching for signs of the elusive Higgs boson, also known as the God particle, and other anomalies that might shed light on the fundamental components of the universe. By focusing on the microscopic, we unlock insights into the macrocosmic world. But with each answer, new questions arise. With every discovery, a new challenge surfaces. The LHC isn't just a scientific tool, it is a representation of human curiosity and advancement. It represents our relentless pursuit of understanding and our desire to unlock the fundamental forces that govern our universe. However, as we push the limits of our knowledge, we must also confront deeper existential questions. What risks lie in probing the unknown? Could our quest for knowledge inadvertently unleash powers beyond our control? A startling revelation has surfaced within CERN, where human understanding is constantly expanded, causing even the most seasoned scientists to pause. Brian Cox, a former CERN scientist and an authoritative voice in the realm of particle physics, recently shared a statement that has both captivated and unsettled the world. His words echoed with unsettling clarity. The LHC at CERN aims to replicate a miniature Big Bang. Yes, that's right, a miniature version of the very thing that gave rise to our universe. The physicist also elaborated on the implications of this objective, highlighting the LHC's immense potential to make groundbreaking discoveries, including uncovering the secrets of the Higgs boson and delving into the enigmatic world of dark matter, which constitutes a large portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very essence of the universe. It's a tempting possibility, but it also comes with risks. The mini Big Bang is not just a theoretical concept, it is a tangible reality within the LHC. The extreme temperatures, pressures, and raw energy simulate the conditions present at the birth of the universe. It's like standing on the brink of recorded history, witnessing the inception of existence itself. But with such power comes great responsibility, and the pressing question remains, what if something goes wrong? In fact, something did go wrong in 1978. Russian physicist Anatoly Bugorsky experienced an accident that could forever alter his life while working at the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia. A malfunction caused a proton beam to strike him. The beam, with a force beyond comprehension, passed through his skull, entering the back of his head and exiting through his nose. His experience was terrifying. He saw a flash brighter than 1,000 suns, yet had no immediate worries. The proton's path left behind a trail of destruction, burning tissue and bone. But astonishingly, he remained conscious and even walked to seek treatment. The outcome was unsettling yet surreal. The proton beam caused localized tissue damage, leading to partial hearing loss in one ear and facial paralysis on one side. Remarkably, Bogorsky's cognitive functions remained unaffected, and he continued his career in science. This incident serves as a stark reminder of the immense power and potential dangers inherent in particle accelerators. The risks associated with machines like the LHC should not be underestimated. The possibility of catastrophic reactions, where the very fabric of life is altered, is not the stuff of science fiction, but a real concern voiced by esteemed scientists. The possibility of a miniature black hole being produced by the LHC experiments is one of the most fascinating and unsettling aspects of the project. Black holes are regions in space where gravity is so intense that even light cannot escape. These cosmic vacuum cleaners devour stars and are mysterious entities hidden in the shadows of our universe. The possibility that the LHC could generate one of these phenomena, even on a small scale, is both awe-inspiring and terrifying for the public and scientists alike. Could this black hole grow uncontrollably and eventually consume the Earth from within? CERN scientists have reassured the public that any black hole generated by the LHC would be unstable and would disappear almost immediately. Still, the mere prospect of such an occurrence has sparked debates, fears, and wonder at the power humanity wields. It's important to understand how the LHC could create a black hole. The answer lies in the basic mechanics of particle accelerators. When protons collide at near light speed, the energy produced is so vast that it distorts the very fabric of space-time. Imagine a trampoline stretched taut, and then a heavy object is dropped onto it. The fabric bends, and if the object is sufficiently heavy, it creates a well deep enough to draw anything nearby into it. This serves as an analogy for what could happen inside the LHC. Within the realm of quantum physics, where the laws of the universe are often strange and awe-inspiring, a hypothesis exists that suggests there could be more dimensions hidden within our reality. If these dimensions do exist, the LHC's experiments might tap into them, creating a gravitational well that forms a small black hole. This bizarre interaction of particles has even caught the attention of prominent scientists, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the Higgs boson at extremely high energy levels. Such instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy the Earth but could potentially erase the entire universe. The renowned cosmologist and physicist Sir Martin Rees has also voiced concerns about CERN's experiments in his book, Our Final Hour, where he explored the risks associated with particle accelerators, including the LHC. His words were not only cautious, but filled with existential apprehension. Rees examined a worst-case scenario in which a failed experiment could trigger a phase transition, rippling through space-time and creating a disaster that could engulf the entire universe. Though Rees assigned a low probability to these catastrophic outcomes, he argued that even a small risk deserved serious consideration. The stakes are enormous, and the margin for error is razor-thin. Scientists at CERN have run countless simulations, analyzed theories, and implemented rigorous safety protocols to ensure the LHC's operations are as safe as possible. Brian Cox himself emphasized the importance of these precautions, acknowledging He reassured the public that the energies involved are well within Earth's natural range and that the chances of creating a stable black hole are extremely low, all in response to concerns about the LHC's operation. Even if a black hole were created, scientists argue it would be so tiny and volatile that it would quickly dissipate, releasing energy in a phenomenon known as Hawking radiation. It would be a brief moment of cosmic wonder, a fleeting glimpse into the void before it vanished forever. The idea that the LHC's experiments could open a door to a different universe or dimension has been taken even further by some. While this theory is largely dismissed by the scientific community, it has captured the imagination of many, becoming a topic of fascination, fear, and myth. Beyond our universe, what might there be? Could we unknowingly unleash forces or entities we do not yet understand? The notion of opening a portal to another realm has even been sensationalized by various media outlets, fueling uncertainties and fears. But where did this idea originate, and what does it mean in terms of scientific inquiry? Physics has long considered the possibility of hidden dimensions. String theory, a leading candidate for a unified theory of everything, suggests there may be more than the standard 3 dimensions of space and 1 of time. These extra dimensions could be compact or hidden from our perception. However, under extreme conditions, they might be accessible or revealed. Now, picture the LHC as a huge key that opens doors that have been locked since time began. When protons collide with energy levels never before achieved on Earth, they could, in theory, create ripples that probe these hidden dimensions. If these dimensions exist, the LHC may uncover them. Yet, before we get too excited with wild theories, it's important to recognize that, while the LHC is immensely powerful, there is no definitive evidence suggesting it will open a door to another universe or, as some fear, to hell itself. Still, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that these ideas will continue to captivate our collective imagination. Should the LHC and its potential dangers cause us concern, it's easy to be swept up in sensational headlines and fears of global catastrophe. However, the truth is that scientists at CERN are acutely aware of the dangers involved. They have taken every precaution to ensure their experiments are safe, continuing to monitor and test their work with the utmost care. The potential rewards of their research, such as breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly remarkable. The LHC not only showcases human ingenuity, but also offers a glimpse into the very heart of the universe. However, as with any major scientific advancement, the risks should not be ignored. We must approach these discoveries with a balance of awe, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics converges with experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is immense. Yet, despite the rigorous safety measures and extensive simulations, the LHC continues to inspire a sense of mystery and trepidation. In sum, the sheer scale of the machine and the energy it generates are awe-inspiring, and each new experiment opens doors to uncharted scientific territories. While most scientists remain confident in the safety of LHC experiments, there will always be fundamental uncertainties. What if unexpected anomalies emerge that challenge our understanding of physics and the universe itself? The LHC is testing our control over the natural world and pushing human knowledge to its limits. As particle collisions simulate conditions, from the earliest moments of the universe, existential questions about the impact on the fabric of reality grow ever more pressing. The ongoing experiments at the LHC continue to challenge the boundaries of human knowledge. While the insights they may yield could dramatically expand our understanding of the universe, there's an undeniable tension between the quest for discovery and the potential dangers that come with pushing scientific limits. As scientists probe deeper into the mysteries of particle physics, they risk uncovering truths that could alter our very perception of reality. The possibility of unraveling new dimensions, detecting exotic particles, or unlocking the secrets of dark matter presents immense opportunities but also potentially uncharted risks. Could the LHC experiments have consequences that we are unable to predict or control? The public's fascination with the LHC often focuses on its potential to cause cataclysmic events or to uncover secrets that could reshape humanity's place in the universe. However, this fascination should not overshadow the careful, meticulous work done by the scientists involved. Despite the risks that accompany high-energy particle collisions, the safety protocols in place are designed to minimize potential hazards. Scientists involved in the LHC experiments have undergone rigorous training, and the operations of the collider are monitored and reviewed at every step. Yet, the sheer scale of these experiments and their implications often lead to speculation that goes beyond the realm of science into the realm of myth and conjecture. While sensational ideas of alternate dimensions or other universes might fuel media narratives, it's important to note that there is no empirical evidence to suggest the LHC will open these theoretical gateways. Though it is true that some theories suggest the possibility of multiple dimensions, these ideas remain speculative, and the LHC has yet to show any definitive proof that it is unlocking such mysteries. The LHC's purpose is not to prove these theories, but to explore the basic building blocks of our reality. Despite the intense scrutiny the LHC faces from both the scientific community and the public, it remains one of the most advanced tools we have for understanding the universe at the most fundamental level. The collider's potential to answer deep, unanswered questions about the origins of matter and the forces that shape the cosmos is unmatched. These breakthroughs could lead to advancements in technology, medicine, and our general understanding of the universe that we can barely imagine.